Another kind of non-parametric test is the Friedman test. The Friedman test is a version of the repeated measures ANOVA that can be performed on ordinal, that is, ranked, data. So here's some ordinal data displayed in a table. Is there any difference between weeks 1, 2, and 3 using alpha 0.05? Now remember, this is kind of like a repeated measures ANOVA, because here we have 6 subjects and we're measuring them 3 times, week 1, week 2, and week 3. So let's do a hypothesis test for the Friedman test using the same 7 steps that we usually do. Step 1, which is to state our null and alternative hypotheses. So our null is that there is no difference between the 3 conditions, and our alternative is that there is a difference somewhere between the 3 conditions. Our alpha, like I said, is just going to be alpha equals 0.05. For our degrees of freedom, we're going to use degrees of freedom equals k minus 1. K is the number of groups we're comparing. Here we have 3 groups, so 3 minus 1 is 2. Our analysis will use 2 degrees of freedom. And now we'll use those degrees of freedom to find our decision rule. Now this is going to follow the chi-square distribution. So looking at this chi-square table, with an alpha level of 0.05 and 2 degrees of freedom, we find a critical value of 5.99147. That means that if we calculate a chi-square value greater than 5.99, we're going to reject the null hypothesis. Next, we will actually calculate that value, which is our test statistic. So here's our data. I just moved it over a little bit, and now I'm going to duplicate it so I can show you something. These scores that I have indicated in red, 27, 20, and 34, remember, those all come from the same person at week 1, week 2, and week 3. What you need to do is rank those scores within the row, like this. So for example, 27 is the second highest score, 20 is the lowest score, and 34 is the highest score. So we put in 2, 1, 3 to rank that person based on all of their other scores. And we're going to do that for all 6 subjects. And now we can throw away the original data and just use these new ranks that we've calculated. Now we need to find the rank for each of the columns. So the total rank for week 1 is 9, the total rank for week 2 is 14, and the total rank for week 3 is 13. And we're going to use these 3 r's in our chi-square equation, which is pretty easy because we know that n is 6, we know that k is 3. We just need to solve for the sum of all r squared, which looks something like that. The sum of all y squared is just 9 squared plus 13 squared plus 14 squared. And then we put in n and k, and suddenly the equation's pretty easy to figure out. You just put that in a calculator and you find out that chi-squared equals 2.33. So to our results, remember we were going to reject if chi-squared was greater than 5.99, and our chi-squared was 2.33. So we will not reject the null hypothesis. We can conclude that there is no difference among the 3 groups using a Friedman test.